Hello, nerds, algebra students. Mr. Lawrence here. Well, I'm not really here, but you're listening to me, so that's a good thing. I'm resting my back today, guys. Sorry, I've been so much discomfort the past couple days. Thank you for being so wonderful and doing your job. You guys are working so hard. You make me want to come in and teach when I'm not supposed to. So I'm going to take the day off, okay? Hopefully I'll be good to go by Monday. All right. So today we are going to start with the big F word. Yes, that's right, the big F word, factoring. All right. Now, it's important that you realize the first type of factoring you should always try is achoo. Oh, it didn't work. My sneeze didn't work. Achoo. There we go. GCF, the greatest common factor. And we did that a couple days ago, I think maybe on Wednesday. We factored by the GCF, right? So let's take a look at examples 1 and 2. So I'm looking for a GCF here. Now, did I mention that this is the first type of factoring you should always try? Always try. I don't care what the situation is. We're going to learn like 5 or 6 different types of factoring situations. You're going to have to practice a lot to know when to factor using which method. But the first type of factoring you should always try, GCF, greatest common factor. Always, always, always. So I'm going to look over here. The greatest common factor of 6x squared plus 9x minus 12. The GCF is going to be, well, the GCF of the coefficients is going to be 3, right? Because the GCF of 6, 9, and 12 is 3. Now, the GCF of the variables is just plain old 1, which doesn't help me because there's no x term over here. I can't pull an x out because I'd have to have an x on all 3 terms. I could add an x cubed here, like if that was x cubed, then I could say the GCF, but I can't do it in this case because there is no x term there. It's just a constant. So my plain old GCF is 3. I'm going to pull a 3 out, division, right? Which will give me 2x squared plus 3x minus 4. Now this might be able to be factored further, but we're not ready for that yet. So we're going to stop here with this problem. It might be able to be factored more, but we're not ready for it. A couple days we'll be tackling that like nothing. All right, so this problem for all intents and purposes today is done. All right. There we go. We just factored by the GCF. Why don't you pause the video and factor number 2 by the GCF? Okay, here we go. So I'm going to factor out my GCF. Well, my GCF of my coefficients, I think is 8, right? I think 8 is the greatest common factor between 16 and 24. And then of my variables, do you remember the shortcut? It's always the smallest exponent. So it'd be x to the 4th. So I'm going to factor out an 8x to the 4th. And remember, this is division because it's like undistributing. So if I divide 24 by 8, I get 3. And x to the 4th divided by x to the 4th cancels. So I just get a 3 there. All right. 16 divided by 8 is 2. X to the 5th divided by x to the 4th is plain old x. And there you go. This cannot be factored anymore. And it has been factored by the GCF. All right. Now we're getting down to it. We're going to learn to factor trinomials when a equals 1. Well, what the heck is a? Well, you need to know standard form of a quadratic. A standard form of a quadratic, and we will add to this later, but just for a quadratic expression is ax squared plus bx plus c. This is why I'm always having you write them in this order, if you notice that. Okay? So we're only going to factor situations where a is 1 today. Later on, we'll do situations where a isn't 1. So let's take a look at these 2 examples, and then you can try a couple examples. All right, this first one. I've got x squared plus 5x plus 6. I'm going to break this into 2 binomials. Yeah, I'm going to make it into 2 binomials. The first thing I'm going to do is I'm going to list the factors of 6. And I don't know if you notice, Mr. Lawrence is very systematic when he does his factors. He starts with the smallest and greatest factors, 1 and 6. And he goes to 2 and 3, and now he knows he's done because there's no whole numbers between 2 and 3. All right? Here's what I need. Because the 6 is positive, it's addition. Did I mention because the 6 is positive, it's addition? I need 2 factors of 6 that add to get positive 5. Let me say that again. I need 2 factors of 6 that add to get positive 5. They're adding because the 6 is positive, and the sum needs to be positive 5. All right? So, I know, how about 2 plus 3? Does that make positive 5? It sure does. Here's how this factors. We're going to have 2 quantities. And we're going to have an x plus
Taylor
2
Terracosi to the
and an
office.
x plus
Taylor
3.
Terracosi to the
And there
office.
you go. It is factored. That trinomial, quadratic trinomial, turned into two linear binomials being multiplied. All right? I needed two factors of 6 that add, because that was positive, to get positive 5. Let's take a look at this one here. I'm going to need two factors of 12. So I'll list 1 and 12. And then I'll list 2 and 6. And then 3 and 4. Okay? I need two factors of 12 that add to get negative 7. Well, how about a negative 3 plus a negative 4? Or better yet, negative 3 minus 4. That's an addition problem, isn't it? This is going to factor as x minus 3 in a quantity and x minus 4. Now, if you're not sure if you did it right, you could always double distribute and make sure you get x squared minus 7x plus 12. Not a dumb idea. So did you see how I did that? I needed two factors of 12 that add to get negative 7. All right, I want you to try numbers 3 and 4 here. Pause the video, see if you can do them. Okay, here I come with my solutions. First one, I'm going to need two factors of 15 that add to get 8. Well, that's going to be an x plus 5 in one quantity and an x plus 3, right? Did you notice that since this is positive, B's sign showed up in both quantities? Yeah, did you notice that? On the previous one, problem number 2, we had B was negative, and sure enough, we had minus 3 and minus 4. That's not a coinkydink. No, it is not. All right, so hopefully you did number 4. If you haven't, pause the video and try it. Here comes my solution. I need two factors of 36 that add to get negative 13. Well, that's going to be an x minus a 9 and an x minus a 4. Now somebody's saying, no, Mr. Lawrence, it's x minus 4 and x minus 9. But if you know the commutative property, you know both those answers are the same. So there you go. We just factored. Okay, couple more examples here. Now, in this case, 5 and 6, the C term is negative. I still want the factors of 12. 1 and 12, 2 and 6, 3 and 4. I know I'm done. But I'm not going to add them this time. I'm going to subtract them. Why am I going to subtract them, Kyle? Because the 12 is negative. So I need two factors of 12 that subtract to get negative 4. I want negative 4. Well, how about 2 minus 6? 2 is positive, right? This is going to factor as x plus 2 and x minus 6, each in their own quantity. Bam, it factored. I love factoring. I'm a factoring fool. Oh, this is so much fun. All right, number 6. I need factors of 15. 1 and 15. Okay, 3 and 5. And that's it, because 4 doesn't go into 15 evenly. I need two factors of 15 that subtract to get positive 2. Well, 5 minus 3 would work, wouldn't it? 5 minus 3? So I'm going to need an x plus a 5 in one quantity and an x minus a 3 in another quantity. There you go. And again, you can check your work by double distributing. All right. Here's two more examples for you to try. Go ahead and pause the video, give them a shot. And while you're doing that, oh, where'd that go? I'm going to go ahead and create one more special problem. Okay, so hopefully you have factored 7 and 8. Here come my solutions. And notice problem number 9 showed up there. Hold on a second. Something's in the way. Let me get rid of that. There we go. Okay, but let's talk about 7 and 8. For 7, I need two factors of 12 that subtract to get 5. Positive 5. 1 and 12. 2 and 6. 3 and 4. I don't think I can get 5 out of that. No, this one's going to be prime for right now. This one's going to be prime. There aren't two factors of 12 that subtract to make positive 5. Mr. Lawrence must have made a goof somewhere, but it's okay. All right. On number 8, I need two factors of 24 that subtract to get negative 10. Ooh, I think I just found them. 2 minus 12, right? 2 minus 12. 2 minus 12, not 2 minus 10. If I see the factors right away, I don't have to list them all out. So I'm going to get an x plus 2 in one quantity and an x minus 12 in the other. And there it is factored. All right, now, number 9 here. What's the first type of factor you should always try? If you were paying attention earlier, you know it's GCF. I see a GCF in here. I do. I see 3. I think I can pull a 3 out. I'm going to divide by 3 and get x squared minus x minus, well, let's see, 126 divided by 3. I think it might be 42. Minus 42. I factored out the GCF. Now I can continue to factor inside. I need 2 factors of 42. 1 and 42. 2 and 21. 3 is going in. How many times? 14, I think. I think that's right. 28, 42. Yeah. 4 is going in. Nope, it's not. 5, no. 6 times 7 is 42. And I know I'm done because there's no other whole numbers between 6 and 7. Or integers. I need 2 factors of 42 that subtract to get -1. Well, how about a 6 minus a 7? So this 3 is still out front, doesn't get thrown away. Then I have 2 quantities. And the first quantity could have an x plus a 6 because the 6 is positive, and then an x minus a 7. All right, and there you go. So look for that. The first type of factor you should always try, GCF. And then, if it's a quadratic trinomial and a is 1, you should know how to factor it. It shouldn't be that tough. All right, that's it for the video. I want you to work on Excel 8.5 the remainder of class and finish over the weekend if you need to. Hopefully I'll be good, ready to go. Not so crabby on Monday because my back will feel better. I love you guys. You've been working hard. Keep it up. Have a good night, everybody. Bye-bye.